All right, so on these notes, you're going to title it Postulates and Theorems about segments. Guess what we're going to cover on Monday? Postulates and theorems.
About segments.
About, not lines. Close, keep going. What's the other thing that we can measure?
Segments.
We measure segments and what else? Angles, thank you. So Monday we're going to cover postulates and theorems about angles.
It is still going. I told you that.
Josh, you're gonna have to restart that.
I can't.
Why?
If it's doing that, you can't do anything. It can't even turn it on. Get away for it to die. It won't die. It was last for like 4 days.
All right,
Oh my god. Oh, yep. You're
let's go. The first postulate is called the ruler postulate. What the ruler postulate does is it shows you how to use a ruler. What's the question was?
Could you use a different color?
Yeah.
Yeah.
It's really hard to get it.
All right, so just listen, I'll change my color after this one. So all the ruler postulate does shows you how to use a ruler.
That's seriously man.
Hey, yeah, and I'm going to show you what it does here in a second. Is that better? Black?
Oh yeah. That's a lot better.
So all it does, if you have this segment, AB, you take the ruler, and the ruler postulate says, you place the end of the ruler, match it up with one of the points of the segment, and then where the other point lies on the ruler tells you the length. Is that too hard for you, Josh?
I just had a little bit in my head.
So the ruler postulate is sort of silly. Again, postulate's a lot of common sense stuff. The rest of them won't be quite that silly. Segment addition postulate. This one we sort of already covered this year. Segment addition postulate. Remember with the segment addition postulate, I'm just going to draw this. We did this chapter 1. I'm just going to use the picture to show it.
All right.
So let's even put this. We'll put if you have this picture, we'll write it as an if and then statement. Then what can you say from all that? Not just Q. What's the first segment? QR, segment QR plus
RP.
segment RP equals segment QP. All right, remember that was the segment addition postulate. We done those on the chapter 1, and you had them on the chapter 1 test. This segment plus this segment has to equal the whole thing. Now, could you have a segment subtraction postulate? Could you say the whole thing minus segment RP has to equal this? Yeah, you could. They don't do that because
It's obvious.
it's just sort of obvious. The next one, reflexive property. Reflexive property. What did we say the reflexive property said in algebra? A equals A. And the way we're going to write reflexive property out here, and this is going to be on some of the definition tests and stuff that we take. So make sure you know what it is. Anything, and I know that's not a good word as far as using it in a definition. Anything equals itself. Some of you are writing papers maybe for your English class, because I was editing one for somebody yesterday, and they used the word thing in there about 10 times. Do you ever use the word thing in a paper when you're writing a formal paper? You wrote stuff like, they did this and other things. No, then you tell what they did. You don't, it's a paper. Don't put, they did a bunch of things. They did a bunch of stuff.
Yeah, just trust me on that.
Alright, so that's a reflexive property. The other properties that we covered last time go along with reflexive property. You have, I don't remember the name of it. You have symmetric property, and I'm going to do these two together. Symmetric and transitive properties. Symmetric and transitive properties also work for segments. That's all they're telling you here. Work for segments. So they worked in algebra. Any algebra stuff, they also work on any segments. And I'll write them up, an example of each one up here just to help you out. Symmetric property says segment AB is congruent to segment CD. Then symmetric property, remember, all it does is do what to those two things? Flips them around. So then we know segment CD has to be congruent to segment AB. Transitive property, just real quick. Transitive property, segment AB equals segment CD. Segment CD equals QR. And then we know AB equals QR. Make sure. That's the assignment. We were going to work some of it in class. We're not going to have time. Page 104, 12 through 19, 21 is like 13 problems or so. 40 through 45. What I'm going to start you off with, postulates and theorems. You're going to, in your book, I'll give you just a couple of minutes to do it because I want to make sure that we get on to the lesson. Book. In your book, you're going to go to the purple section that I explained to you where it was in the back a couple days ago, whenever that was. If I can ever find it. And for a few minutes, and normally I won't give you this time, for a few minutes, you're going to copy down postulates and theorems from here. All right? This is the third section for your binder. All right? This goes in your binder. Start the third section. When you're doing this in your binder, I want, this is going to make it easier on you. Your first section should be your notes. So that's section 1. Section 2, postulates and theorems. Third section is going to be your tests and quizzes. That way, if I ever do again, which I probably won't, but if I ever allow you to use your binders on a test, you can't use this third section. So it would make it easy to take out. All right? So all you're going to do, you go to the back of the book, this section right here, start copying down each of those postulates and theorems on a sheet of notebook paper. Don't do like I have this bad feeling that my friend Damien's going to do and wait till the last minute, because if you got 50 postulates and theorems this 9 weeks, and at the end of the 9 weeks your binders are due, You think you're gonna go back and copy them all? What's gonna happen?
But it's not gonna be in there.
You're gonna look at them, you're gonna think, oh crap, I don't wanna do all these. So if you do 8, 10 of them right now, 8, 10 of them next week when we get to them, is it gonna be that big a deal? No. So don't sit here and do nothing, actually copy them. As you're copying them, the first one says this, postulate 2.1, just to make it easier on you, this is what I would do. P 2.1, then write it down. Next one says postulate 2.2. All that's going to be in there is postulates and theorems, so you can abbreviate a little bit, make it a little easier on yourself, a little less writing, instead of writing out the whole word postulate every time. Okay? Does everybody understand all that? So you got a few minutes. Here in a few minutes, I'm going to send Chase around. He's going to check the homework, so have page 97 just laying out there somewhere. You wanted to check? Yeah, Chase does. Okay. So have page 97 laying out so that when he comes around, you'll be able to show it to him. Page 97, questions. Everybody should have their books open, follow along. Yes, Jalen. 23. Finish up with the postulate theorem that you're on right now. If you need time to copy more of them, then it can be part of your assignment. 23. Which property could be used to support the statement EF? Is EF a segment, a line, or array there? Segment. How do you know it's a segment? Because it's got an equals with it. Can't be a line, can't be an array if it's equal to something else. So segment EF equals segment JK. EF equals segment GH. I'm not sure why I put that segment symbol above that, because it didn't have it. So if I know EF equals JK, then EF equals GH, what conclusion can I draw? I know they give it to you, but you could sort of use that. What conclusion though first? That's the property. I know this equals this equals that. What do I know about these two then? JK equals GH. Now, Chase said the transitive property. Is it really the transitive property? Remember, with transitive property, is this in the right order to be transitive property? This one's backwards, isn't it? It'd have to say JK equals EF, then EF equals GH to use the transitive property. But what could I do with this? I could turn it around. I could make it JK equals EF. Then it would fit the transitive property. So not only did I use the transitive property, what property tells us I'm allowed to just flip that around like that? Symmetric property. Now, the other thing you could have used, if you wrote it that way, that's fine. That's not really the way they wanted you to go. The way they wanted you to go, if you know EF equals JK, EF equals GH, well, in place of EF right here, what could I stick in? JK. What property did I use there? When I stuck something in place of something else, what's that called? Substitution. Substitution property. That's what they actually probably wanted in this case. Next question. No others?
Thirty.
30? Problem 30. No, they took it out. Yeah, before I write all this, whenever it says if and then, the if part is your given information, the then part is what you're trying to prove. So I'm just going to write it that way. Given segment XZ equals segment ZY. They also give us that XZ, what is it? XZ, and then they probably tell us ZY equals something too, don't they?
Yeah, ZY equals 6x minus 13.
So that's all our given information. What are we trying to prove? 7? X equals 7? All right, so that's what we got. And they give you a picture. Looks like this. And they label it all for you already, so what is it, X, Z, Y. And they tell you that this is 4x plus 1, this segment's 6x minus 13. We go to write this 2-column proof. If you shorten this up and just put S up here and R, I don't mind that. What's our first statement going to be?
X, 2, wait,
It's a Z.
Z,
Equals,
Y.
how'd you know that XZ equals ZY?
Can't do it.
Oops, I don't know why I put a 2 there. That was given. Now watch, because we're going to take a test next week over these 2-column proofs, and this is how I'm going to count these on the test. That's 1 point, that's 1 point. Austin, should every single one of you be able to get those 2 points?
Yes.
Yeah. Now watch what's going to happen here. What's our second statement going to be?
2x, XZ equals
XZ
4x plus 1.
equals 4x plus 1. Notice the book, a lot of times, they'll stick all the given in one statement. I don't want you to do that. I want you to separate them. Because when I'm grading it on the test, that's a point, that's a point. Well, what's this? A point.
That's why I said 3 points.
Yeah. So, how did we know that?
Given.
That was given.
That's another point.
That's another point. What's our third statement going to be?
ZY equals 6x minus 15.
And how do we know that?
Another point.
It was given. So right now, how many points you got? You got 6 points, and you haven't done anything. Now you got to start doing some work. If I know this equals this, XZ equals that, ZY equals that, what equation can I set up?
The whole thing.
So tell me how to write it.
ZXY. No, XZ. Okay.
Look at what I have here. I'm going to take out this XZ. What can I put in its place?
4x plus 1.
4x plus 1. I'm going to take out this ZY. What can I put in its place?
6x plus 2.
Now, do I have an equation that I can solve?
Yes.
Oh, by the way, you put 13, that's 3.
Let's go back.
It's supposed to be plus 1, not plus 3.
Oh, it's supposed to be plus 1 here?
Oh, wait, no, I was looking at the wrong thing, that's mine.
Oh, confusion.
Shit.
How do we know that? What did we use?
Substitute.
Substitution property would work. All we did was substitute in place of that, in place of that. Now all we're going to do is solve. What's the first thing we do to start to solve that?
Add like term.
Do you have like terms on this side?
Oh.
This side? So what's the first thing we do?
U minus X
Minus 4x on both sides. That leaves us with 1 on this side. What's left on the other side?
minus this
2x minus 13. How come 2x?
We did
Subtracted 4x on both sides, right? What told us we were allowed to do that? What property? Subtraction property,
Now, you can do it again.
subtraction property. Now what?
And then it's add 13, so it's
Add 13 to both sides, what that gives?
14,
Equals,
2x.
what's that tell us? Addition, or how do we know that, I mean? Addition property, not just addition, right? It's gotta be addition property,
And then you
7. Divide both sides by 2, what's that leave you with? 7 equals x.
Correction, just a reminder to all staff that we are giving the flu shots over in the elementary conference room from 10 to noon today. Just a reminder.
Division property. Are we finished? Be careful.
No.
What they ask us to solve for, or what they ask us to prove. X equals 7. Is that what we have?
Yes.
You gotta switch it around, right?
Yeah.
I know this doesn't seem like a big deal, because last year in algebra, when you switched it around on your paper, you just switched it and didn't bother to even tell anything about it or anything, right? What property allows us to turn that around like that? Symmetric property. Symmetric property. So if you have to switch it around like that, it's just a symmetric property. So looking down through this, worth how many points?
1,
1.
1, 3, 4, 5, 6.
So you got 6 points right there. The whole thing is going to be worth how many total?
16.
16. So you got 6 out of 16 for doing nothing but writing down the given stuff. All right?
That's 50%.
Almost 50%. 8 out of 16 would be 50%. All right, so but you got 6 points just for doing nothing. All right, what you're going to do today, I'm going to write down some notes up here. You're going to copy them. First part of the notes, I want you to write just what I have right here, postulates and theorems, but add this to it. About segments. Postulates and theorems about segments. That's going to be the title. So all those postulates and theorems that you just wrote down, what we're going to do, we're going to go over them a little bit. Make sure you're writing this down. The first one is called the ruler postulate. And if you read the ruler postulate as you were writing it down, you're probably thinking, well, that's just stupid. And you're sort of right. The ruler postulate, all it does is shows you how to use a ruler. Now you ought to feel real stupid if you wrote that down and didn't have any idea that that's what it was telling you. I'm hoping all of you figured it out. All it does is this. Gives you a segment. Maybe it's segment AB. It tells you if you take a ruler and I want to measure it, I don't do this. I don't do this. I don't do this. Knock my thing off the wall. All right? I do what with my ruler?
Put the end on it.
Put one end on one of the points and the other end will go out to the length of the segment. So you have this ruler. You line up this end with point A, and whatever it says out here is the length of the segment. That's all the ruler postulate tells you.
What does this mean?
What?
What's this mean?
Oh, 18. The second one. Segment, this one's important. And I already told you it was important earlier this year. Segment addition postulate. Right. Segment addition postulate. Segment addition postulate, I'm going to write it as an if and then statement. If, and I'm just going to give a diagram here. If you have that diagram, and we did these in chapter 1, they were on the chapter 1 test. If you have that diagram, what can you tell me about the whole segment there?
PQ plus P, PQ plus QR equals PR.
Very good. So all Zach just said, this segment plus this segment has to equal the whole thing. That's what the segment addition postulate says.
Would this be transitive?
This part plus this part equals the whole thing. No, transitive property says things are equal. Make sure you know segment addition postulate. Remember chapter 1 we had stuff like where they'd stick in that segment equal 2x. This segment was 3x plus 4. The whole thing was 32. You'd have to say 2x plus 3x plus 4 equals 32. Solve for x and then maybe plug back in to find the other segment or whichever segment they asked you for. The next one, reflexive properties. Yeah, you're supposed to be writing these down. Reflexive property. What did we say the reflexive property said in algebra yesterday?
Like A equals A.
A equals A. And what I want you to write down for reflexive property, and we are going to take a definitions test here real soon, hint, hint, like next week. And on this test, hint, hint, and all I want you to write down for it doesn't really have a definition. I just want you to tell what it says. Reflexive property says anything, not a good term to use, I know, but we're going to use it, equals itself. That's all the reflexive property says. Anything equals itself. I was reading a paper yesterday for a student, and they used anything and things and stuff in there many times, and I was trying to edit it for them. Should you ever use that in an English paper? Never. All right? And I probably shouldn't use it in my geometry notes either, but Jordan, does it make sense that I say anything equals itself? Is that better than me saying
I'm really confused.
all segments equal itself, all angles equal itself, all numbers equal itself, so on and so on. All floors equal itself, all chairs equal itself. Exactly, so that's what I want to get to there. The next two, I'm going to put these two together. Symmetric property and transitive property. All we're going to write on this one, remember symmetric property, we just got done doing this a second ago. Chase told us what it was at the end of that 2-column proof. What's the symmetric property do? Just switches the two things, all right? We'll get transitive property here in a second. Transitive property was that easy one that everybody remembers. Nobody remembers the name of it, but everybody remembers what it does. All they're telling us on both these is that both these properties work for all segments. So what they're saying is, not only do these two properties work in algebra, but they also work for segments in geometry. Symmetric property, I'm going to give you just a little quick example here. If segment AB equals segment CD, then using the symmetric property, what can you say? CD equals AB. All right? So you can make this conclusion right here from that if statement. That's what the symmetric property does. Transitive property says if segment PQ is congruent to segment TN. Notice when I'm writing this, over here, did I use the segment symbol? Because I was using the equal sign. When you're doing algebra stuff, you don't have to use the symbols. When I threw the congruent in there, did I use the segment symbols?
Yeah.
Yeah, so when you have congruent, use the symbols. When you have equals, don't use the symbols. This is algebra form, geometry form. If segment PQ is congruent to segment TN and segment TN is congruent to segment NC, then what conclusion can we come up with? Very good. PQ is congruent to segment MC. We can then come up with that conclusion. All right. Now, remember for transitive property, it has to be in this order. You see the TN here? It has to be the first thing over there. Has to go in that order. So it sort of matches up right along. Like you could just shove them together. Maybe that's a good thing. I could just take these two statements, shove them together until the TNs disappear, and you're left with PQ is congruent to MC. All right, the other thing I want to say, because on your homework, you're going to be doing some two-column proofs. What they do on the two-column proofs, and if you look at the examples, that'll help you out a bunch. But if they switch from algebra form to geometry form or geometry to algebra, your reason is always going to be the definition of congruent segments. All right, definition of congruent segments. So if they switch from equal signs to congruent signs or the other way around, that's all you got to write as your reason. Definition of congruent segments. I know Austin's looking at me like, what? What are you talking about? When you get to the problem, you'll say, oh, I see. So we just write that down. All right, your assignment is on page 104. I don't see it till Tuesday, so we have plenty of time to do it